Some of you, if you were here or if you were in Miami last year, you might have seen kind of some of this story a little bit. I'm just going to build on it this year. So I'm going to tell you a bit about our company, how we got started with D-Wave, where we are today, and where we're going. So our company is over 100 years old, and we're privately owned. The first store opened in 1915 in a town called New West, just outside of Vancouver. That store was famous for selling 18 ounces of tea for the price of 16, and soon became known as Overweighty Foods. Overweighty grew organically for the first 100 years or so, to the point where in 2015, we had over 145 locations, 3 banners, with the primary banner called Save on Foods, which is a slightly more appealing name than Overweighty for a grocery chain. We had expanded into 5 provinces. Across these stores, we supported several different types of labor agreements, with some provinces unionized, some not, resulting in 13 different collective bargaining agreements and around 22,000 team members. Today, we are known as Pattison Food Group. We recently merged with 10 additional banners. We have 300 retail locations across Western Canada and the US. We have also vertically integrated into manufacturing and transportation. So we have a cut fruit plant, a meat plant, industrial bakery, and pharmaceutical distribution, as well as transportation. These are our banners. Hopefully you'll recognize some of these. And like many organizations today, we are really investing in technology with a recent focus on data and analytics. And that's really my job, is to leverage the data assets that we have across these banners to provide value for the company, which is where D-Wave comes in. So our relationship with D-Wave began in 2020. Vancouver is a pretty small town, and the tech community there is even smaller. So it was really that old story of somebody in my company knew somebody at D-Wave, and they got to talking. We have several problems in our organization that can't be solved with classical compute. The main one being retail labor scheduling. So I talked a little bit about this in the keynote. Our largest operating cost is labor in our stores. So anything we can do to optimize processes in our stores has huge benefit for the company. And we have looked in the marketplace for systems that could solve problems like auto scheduling, and haven't been able to find any. So when we started talking to D-Wave, we thought, well, let's see if we can build one ourselves. This, just to give you a bit of context, this is what the scheduling process looks like in our stores. So we take the department demand, so how many cashiers do you need at a given time, how many people in the bakery, in the deli, wherever, and then combine that with availability. So who's available to work those shifts, who's on leave, who's newly hired, who's just left the company, who's qualified to work in each department. So have they gone through their food safe training or other training that's applicable? If they're selling wine in our wine department, are they of age? So we consider all of those qualifications, and we combine them with the scheduling rules and constraints. And that's where those labor agreements come into play. So yeah, you can imagine those rules are extremely complex. And it really, in order to build a schedule that satisfies all of those constraints, you need somebody with years of experience. We're talking people that have been working in the stores for over a decade, that understand all of those constraints, who's in each labor agreement, all of that. They put it together, and it takes them about 8 to 12 hours a week per store to build a schedule. They do this 2 to 3 weeks in advance, and then they spend about 3 to 4 hours manually inputting it into our workforce management system. And then in the 2 to 3 weeks from when the schedule is created to when it goes live, there's all the maintenance that has to happen. So who's called in sick recently, any new hires, terminations. So there's another 8 to 12 hours a week of maintenance that happens. So we decided, well, let's see if we can at least solve that initial problem of creating the schedule with D-Wave. So we did a POC in a non-unionized store to start with, started that in July 2020, and I don't mind telling you, nobody in my company, except for those working on that project, thought it would work. We didn't think it could be done. But it did, it worked. And the results were really promising. And so we got the go-ahead from our leadership team to try it out in a unionized store, which is a harder problem to solve. So we started working on that, and it was put on hold because of COVID. So as you can imagine, in a grocery chain, our world was kind of thrown upside down like everybody else's during COVID, but the predictability of people in our stores, or even the demand in our stores, was kind of all over the place. So it was a difficult time for us to tackle retail auto scheduling because the inputs were all over the place, completely hard to predict. And on top of that, it was not the right time to put any change into the store. They were dealing with enough. So we pivoted and we decided, well, maybe we can solve another problem that's top of mind for the company, and that's our e-com driver auto scheduling. So our e-com business before COVID was, it was growing pretty slowly. We were kind of going market by market to assess the demand, who's ready for delivery or pickup. And it was just kind of chugging along. Obviously, the pandemic hit, the need for a way to safely get groceries just accelerated our plans for e-com. And we went into 100 stores very quickly with next day delivery, and had about 3 to 4 people in our main office dedicated to building the schedules for those drivers. It took about 80 hours a week to do that. The process for scheduling e-com drivers is very similar to the process in the stores. You can see the inputs are almost the same, except instead of having department demand, so how many cashiers do you need, it was really just how many drivers do you need to support a region of stores with delivery. And the effort that it took was different as well. Obviously 80 hours a week, and a little bit less time to input it, and still some effort to do the maintenance. But the problem was very similar, and so we thought, well, this is a great use case. We can deliver something that provides value for the company and also maybe leverage this down the road when we're ready to go back and tackle retail labor scheduling. This is what the process looked like. So my team actually went through and read through the entire collective bargaining agreement. And they spent a lot of time sitting with the schedulers just to understand the problem. So what is the thinking that goes on when they're creating a schedule? They refined all of that into some requirements, converted the requirements to math equations, built a pipeline so that we could have the data flowing through. That converted to optimization code. We had some debugging and parameter tuning that would happen. It would spit out a schedule. We'd go and sit with the schedule writers and say, how does this compare to what you would have done manually or did manually in the past? Make some adjustments, tune the model, and just iterate until we got to a point where the schedule writers were really happy with the output. And then this is how we structure the problem. So the requirements you can see here on the left, and then the corresponding equations that satisfied those requirements. And it becomes a little bit more obvious when you look at it like this, why it can't be solved with classical compute. So meeting all of these constraints concurrently is very difficult to do in a classical situation. Having D-Wave and the power of quantum allowed us to execute this efficiently and scale quite quickly as well. This is the tech stack that we used. So along the bottom, our data was stored in our Azure data lake. We used Control-M to schedule our jobs and orchestration. GitHub was source control and some workflow. SharePoint is what we use to collect the demand from the schedule writers and to publish the results back to them. Databricks is a core tool we use for data transformation within the data lake. And then we had some webhooks with Microsoft Teams that were used to communicate any warnings that were happening throughout the process to our development team. We've got two main pipelines, the data engineering pipeline and the data science pipeline, and both of those were integrated with MLflow to log the results throughout. The data engineering pipeline, so we were pulling in data from our workforce management system, our data warehouse, and SharePoint, as I mentioned, through Informatica's ISCS. That would land into the raw zone of the data lake, and then we used Databricks to transform the data into bronze and silver. And then Python and PySpark was used to convert some of the tables in silver into the data science pipeline. And then we pushed the data to D-Wave's hybrid solver and published the results back to SharePoint. All right, so this is what the schedule looked like. It's probably a little bit hard to see, but if you can imagine, each row on this table corresponds to one driver's schedule for the week, and then the columns are the days of the week. The colors are the different types of schedules, so the hours that they worked and the stores that they supported. And then we've got a column for seniority, ranked from highest seniority down to the lowest. A column for the maximum number of shifts they should get for the week, how many they were actually scheduled for, and then the minimum number of shifts. And you can see this is just the first iteration of the schedule, and it satisfies the demands. It satisfies some of the other requirements, the 10-hour gap, the max-min shifts, availability, and RTO stands for requested time off. So this is just kind of the essentials for our Victoria market for e-com drivers. We iterated, and here you can see now we have shift bunching. So no longer do we have drivers working one day, day off, working another day. They're actually getting consecutive days off. And we've satisfied the cross-week limit, which is each driver can't work a certain number of shifts or more over a 2-week period. Here we've iterated again, and we've added shift seniority priority. So looking through that seniority column, those at the top of the list, the most senior people in our stores, should be getting the maximum number of shifts that they want. That's just how it is in our collective bargaining agreement. That makes sense. So it's starting to look a little bit better, but this is the full deal. So here you can see we've considered historical shifts and job preferences, and you can see that the colors are actually lining up. So if a particular driver likes to support a different store, that's indicated by the color. You can see the most senior person now has consecutive days off, and they're actually driving for the shift that they prefer for the same store. Here's the results. So this is the success criteria that my team was measured on, and really all schedules by and large met these requirements. The weekly manual effort, so it took about 80 hours for somebody to do this manually. It's now down to 2 minutes per schedule using the quantum hybrid solver, and they create about 42 schedules a week. The labor that was saved, so saved by about 80% of the effort spent creating schedules, cut it down from 80 hours to 65 hours. So there is still some time required to tweak the schedule here and there, to consider last minute changes. But by and large, most of the effort is now saved and automated by the tool. This is what our timeline looked like. So we started the development in April of 2022. We did a pilot and then went into production in October 2022. And it has been running smoothly since then. I can say we had planned 2 to 3 weeks at least of hypercare after we went into production. There were no issues. It just worked. So pretty seamless. We had one problem at the end of 2022, just because our fiscal calendar that year had 53 weeks. The team hadn't coded for it, but had nothing to do with the D-Wave solver. It was just something that we had to develop in the pipeline, some extra logic. So great news. My leadership team was thrilled. They were like, wow, you actually did it. This is amazing. Can you go back and tackle that problem at retail? I think we're ready for it. So the same team that worked on CADA, which is what we called the quantum e-com driver scheduling, tackled auto scheduling in the stores. And it worked. It worked. So they leveraged a lot of that same tech stack, the same pipelines. They had to be enhanced a little bit. The model was redefined for the retail problem. The constraints were a little bit more complex, but they coded it and it worked. And we're able to save that 8 to 12 hours per store by automating it. So huge benefit for the company. Not only that, but the schedules are now more consistent. So by automating it, you don't have the scenario where the schedule writer in each store has a lot of power. They're not giving the best shifts to their buddies. It's actually meeting the criteria. It's consistent every week. It's fair, and it's fair across the stores too. So if we have a schedule writer who goes on vacation, you don't need somebody else trying to kind of guess what they would do. The system just works. Not only that, but the people in the stores, because they were so experienced, they have a lot of tribal knowledge about what happens in that stores. And so by freeing them up, they're no longer in the back office. They're actually on the floor. They're training team members, or even more importantly, they're actually working with customers and helping customers. So huge win for the company. On top of that, less dependency on losing that scheduling knowledge. So as some of those more senior schedule writers retire, we don't have to spend decades training somebody to replace them. Anybody can come in and do the scheduling process. The input and the maintenance is still needed at this point, and that's actually a good thing right now because that's helped us with change management. A lot of our schedule writers didn't believe the system could produce schedules as accurate as the ones that they can create themselves. And here they've got that flexibility and control. So the system will just generate a schedule for them, and they can still kind of tweak it here and there, which really helps with them beginning to trust the system. We do measure all of that, just so you know. So we know how much they're tweaking the schedule. But for the most part, they're using it, which is great. So it just works. This is what the timeline looks like. So again, this is the CADA piece, and then we've recently, last year was a big year for auto scheduling. We did a proof of concept and then a White Rock or a pilot in our White Rock location. White Rock is probably our largest store and the most complex store. So it has the most number of team members and the most number of departments. So scheduling in that store is very complex. We started with that store. We're able to solve the scheduling problem fairly easily. But we decided to do another pilot in Poco and Saperton. So those two stores are complete opposites from White Rock, very small. A lot of people working in multiple departments during the same shift, harder, maybe a little bit of a harder problem to solve. So we got some new requirements out of that pilot, developed those, added them to the code, and ended up saving about 1,200 hours in labor with those 3 stores. That's the annual benefit. And as you can imagine, as we roll this out, that number just expands. So as of last week, we were in 33 stores, and today we just rolled out our biggest batch of 25 stores. So we're now in 58. So very exciting. Our plan is to take a little bit of a break throughout the summer, and then by October, we're gonna have this completely rolled out to our Save on Foods BC banner. It's about 120 stores. And then later this year, we're gonna start tackling some of those other banners. My leadership team is very excited about this project, and so is the team. So, yeah, and like I said, the team that built CADA was the same team that worked on auto scheduling, and we really didn't need too much support from D-Wave to create this new product. Very similar problem. They learned a lot in that first one. They were able to apply it fairly easily in the second problem, and yeah. It's just pretty exciting. So when we think about what's next, we want to complete that rollout to the other banners. They have slightly different requirements, so we're going to have to develop those. And the data sources are also different, so we're going to build some new data pipelines. And then that auto maintenance piece that I mentioned, so the 8 to 12 hours of maintenance that happens from when the schedule is posted to when it goes live, we're confident we can automate that as well. If we can do that, that'll double our benefit in terms of labor savings. And then supply chain. So this is, I think, going to be huge for us when we think about applications on route scheduling within our stores and our DCs. Western Canada is very geographically kind of spread out. We've got a lot of challenges getting the products to the stores they need to get to in a cost-efficient way. And so that's probably where we're going to start, but also potentially SKU rationalizations between our distribution centers, slot optimizations within our warehouses as well. Possibilities are endless. That's it. Thank you.